Students, good morning. Today I am going to discuss about the irreversibility and the last work. Irreversibility and last work. Before entering into this discussion, the second law of thermodynamics states that all spontaneous processes are irreversible. All spontaneous processes are irreversible and accompanied by the degradation of its energy. Degradation of its energy. In order to explain in a beautiful or a simple manner, now I am going to rephrase this sentence. All spontaneous processes are irreversible and accompanied by with an increase in entropy. I already discussed it. Take a cup of coffee. It is too hot. Now I am unable to have this coffee. Let us consider a cup of coffee which is too hot. I am unable to have this coffee. Leave it for some time. I have to wait for some time. During this waiting period, the heat content of the coffee gets exchanged with its surrounding. So energy gets degraded. The amount of energy gets degraded is the amount of entropy increased in the surrounding. Clear? Here the amount of energy gets degraded. Here an increase in entropy. The energy lost by the system is amount of work lost. Energy lost by the system is equal to lost work. This is the amount of energy unavailable to do the work. Clear? Amount of energy unavailable to do work. What I am trying to say is this is the work lost. Clear? Now I am going to explain this in a simple manner by a simple process. Listen. A process. Consider a process in which an amount of energy Q is transferred from high thermal reservoir, what we call source. The temperature of source is TH. This is the amount of energy being transferred from high thermal reservoir whose temperature is TH, what we call source, to the low thermal reservoir, what we call sink, its temperature is TL. This is the process. Let us consider a process in which an amount of energy Q is being transferred from the source to sink. The temperature of source is TH and the temperature of sink is TL. Clear? Right. Now I am going to explain the degradation of energy. Based on the source, amount of entropy decreased. Amount of entropy decreased is equal to Q divided by TH. Based on the sink amount of entropy increased is equal to Q divided by TL. In source, entropy gets decreased, but real time there is no process to decrease the entropy in the real time process. This is for understanding. An amount of entropy decreased in the source is equal to Q divided by TH. Amount of entropy increased in the sink is Q divided by TL. The net entropy change, total entropy change is equal to, this is increased, so positive quantity Q divided by TL. This is decreased, negative quantity Q divided by TH. So Q into TH minus TL divided by TH into TL. Clear? Net entropy change, total entropy change in this process. Next, what next? For this process, I am going to use a engine. The engine should be a reversible one because there is no QH, there is no QL. The amount of heat absorbed from source is exactly gets transferred to sink. This is possible only by means of a reversible engine. For this process, I am going to use a reversible engine. Clear? Why I am using this reversible engine means this is Q, this is also Q. The amount of heat absorbed from source is exactly gets transferred to the sink. There is no loss. In such a situation, you have to use a reversible engine. What about the efficiency of this reversible engine? Efficiency becomes work net divided by heat gets absorbed. This is equal to TH minus TL divided by TH. So work net is equal to Q into TH minus TL divided by TH. Clear? Right? For simplification, I am going to multiply and divide by low thermal reservoir temperature. So work net is equal to Q into TL divided by TL for simplification into TH minus TL divided by TH. Clear? Okay. TL into Q into TH minus TL divided by TL. What is this? This is the total entropy change. Hence, I am going to rewrite this equation as work net is equal to TL into total entropy change. Now discussion is open. What is this? If it is a reversible process, this is the amount of work results. This is the amount of work results if it is a reversible process. Reversible process means this is the work, amount of work or net work results. If it is a irreversible process, this is the amount of work lost. This is the amount of work lost, irreversibility. Because all spontaneous processes are accompanied with unavoidable irreversibilities in nature. This is by default. All spontaneous processes are accompanied by unavoidable irreversibilities. If you are having a reversible process, this will be the result of work done. If it is an irreversible process, this is the work lost by the system. It is unavoidable to do work. This is the work lost. Hence, this is the reversibility and work lost. Clear? Thank you.